Here's a more complicated example of using the elimination, where we have to multiply multiple equations by multiple constants to try to help us out. Okay, so right now this equation has a whole bunch of decimals in it. And if you feel comfortable manipulating decimals, you could go with the decimal route. But for most people, it's harder to come up with a least common multiple of 0.3 and 0.5 than it is to work with whole numbers. So a nice way to deal with these decimals is we still have the ability, we can change the way an equation looks as long as we multiply every term by a specific value. Right? So I'm going to first get rid of all the decimals in every equation, right? Because I just want to move this decimal point one to the right, 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 and one to the right. If I can do that, then there'll be no decimals left, and this equation will be a little bit more approachable. So what I'm going to do is I'm going to multiply the whole top equation by 10, because we know if I multiply by 10, it moves the decimal point one spot to the right. I'm going to do the whole thing with the bottom equation as well. So it doesn't really meet my goal of making like coefficients with opposite signs, but it does get this problem started off in a way that makes it more approachable. So we now have 5x plus 3y equals 1, and 12x plus 5y equals 9. Now a more approachable problem, no decimals involved, but we still have this issue of which variable do I want to get rid of, either my x's or my y's, and how am I going to do it? How are they going to match up coefficients with one positive and one negative? So we can approach it two different ways. We could try to get rid of the x's, in which case we would need to find a common multiple between 5 and 12. All right. I'll give you a second to think about it, but it's probably not on the top of your head the first thing that you can think of. 5 and 12, a little bit more difficult to deal with. The common multiple would actually be 60. So we'd have to make each one of these equations, this one have a 60 coefficient, and this one ideally have a negative 60 coefficient. We could do that, but I think dealing with the y's might be a little more manageable. Right, now look at 3 and 5. What's the least common multiple between 3 and 5? Should be 15. Right, so I can make this y have a coefficient of 15 if I multiplied it by a specific value. And I can make this y have a coefficient of 15 if I multiplied it by a specific value. Okay? We would just like one of them to be positive 15 and one of them to be negative 15. So let's make that happen. All right, this top equation we can make have a coefficient of 15 here. Right, we would need to multiply this 3 by 5. Right, so every piece will get multiplied by 5. This bottom equation, if I wanted this to be 15, I don't want it to be positive 15 though, I want it to be the opposite of up here. This already is positive 15, so I want this to be negative 15. So I'm going to multiply this equation by negative 3. Right, every single term, and rewrite our new equations. So 5 times 5. 5 times 3, and 5 times 1. All right, it's easy to forget to multiply by the constant over there. Negative 3 times 12, negative 36. Negative 3 times 5, negative 15. And negative 3 times 9 would be negative 27. Right, now we have two equations that have like coefficients but opposite signs. Now let's add the two equations together. 25x and negative 36x, when we group those, we should end up with negative 11x. These two should cancel, and 5 and negative 27 would end up negative 22. So we canceled out the y's. We did a lot of multiplication by constants that we knew would help us. And now we can solve for x. So we get an x value of 2. we can pick any of the equations that we'd like to use along the way. It doesn't matter which one to substitute to in. So I don't really want to deal with the decimals. I want to deal with the whole number coefficients. So I'm going to choose, I'll choose this top equation to plug a 2 into. So over here we can say 5x plus 3y equals 1. Let's take this, substitute in. 5 times 2 plus 3y equals 1. Solve for y now, add a negative 10 to both sides. 3y is equal to negative 9, and divide by 3. Right, so we have a solution, x is 2, y is negative 3. Remember, we should write that as an ordered pair, 2, negative 3. So here's an example. Right, where this elimination method can be helpful because we can choose whatever we want to multiply the equations by. We chose 10 to help get rid of the decimals. Then we chose 5 and negative 3 to help us get the right coefficients to finish this problem off. So I like this method because it helps us eliminate bad situations. Right? Situations with decimals or situations with fractions. We can choose to multiply by whatever we would like and to help eliminate those decimals or fractions to work with a more manageable system of equations. So, okay. So there's a few problems that you'll have to do the elimination method on.